We're going to learn about continuity in this lecture. So here's the definition of continuous functions. A function f is continuous at a number a if limit x approaching f of x is f of a. So let's understand the properties which needs to be satisfied so that we can say that the function f is continuous. The above definition implies, the definition here implies property 1, the function at a is defined. Property 2, limit x approaching a f of x should exist, which means the limit should exist. Property 3 says, then you can say limit x approaching a f of x equal to fa. So the function f is continuous from the right. Continuous from the right is approaching a from the right, which means the sign will be a plus, and you're seeing x approaching a plus here. F of x is fa. Similarly, a continuous function f from the left at a number a is given by x approaching a minus. So you have a here and it's approaching a from the left, so it's a minus. Still the value of the function is fa. Now the definition. A function f is continuous on an interval if it is continuous at every number on the interval. So if the function is defined only on one side of an endpoint of the interval, then we understand that the continuous at the endpoint to mean the continuous from the right, or it can be continuous from the left. Now we have an example here. From the graph given G, you want to state the intervals on which the function is continuous. So let's start from the left end. I want you to read this interval carefully. It is -4 all the way up to -2. -4, I enclosed a square bracket because there's a dark circle, closed circle. And -2, I'm going to enclose a smooth bracket because I have an open circle at -2. Now, when we read the continuity for this function, when we move in this direction, you're seeing a closed point. So I'm going to say this function is continuous from the right. Whereas when we move from the other direction, we are not seeing a closed point in the end at -2. So we don't say continuous from the left. So because this is continuous from the right, in general, we are going to say this is a continuous function. To be more specific, we are going to say continuous from the right. Then we move on to the next interval, which is just a point, which is -2. The comment you can write for this is just a point. You cannot discuss the continuity just at a point. It should be a nice smooth curve. And you read this as f at -2 equal to 1. So this is not a continuous point. Then you move on to the right, the next curve. You have the interval starting from -2 all the way up to 2. The 2 is having a closed circle, so you close bracket. And the -2 is having an open circle, so smooth bracket. And you're seeing all the points are included here. I'm going to write this is continuous function. And again, if you read the continuity carefully, when the x coordinates are reaching towards 2, the end point at 2 is included. So you can draw a nice smooth line here. You can say that this is continuous from the left, approaching 2 from the left. So continuous from the left. I cannot say continuous from the right because when it comes to -2, you see an open circle. Then move on to the next point. Read the interval carefully. The interval is starting from 2, you end all the way up to 4. So it's 2 and 4, both are smooth because 4 keeps going. At the 4, the curve keeps going like this. You don't have an end point. And you can say that this is continuous. We don't discuss continuity from right or left because you don't have a end point of this curve. One end of the curve is an open circle, the other end of the curve keeps growing. The next one is 4, 6. And again, all you say is just the curve is continuous, but you will not be able to discuss continuous from the right or the left. Then you have exactly a point. So this is just a point. So you will not be able to define an interval on a point. So you'll not be able to discuss a continuity at this point. Then you move on. It is 6, 8. Both are open circles or smooth bracket. All you say is just continuous. You will not be able to say continuous from the right or continuous from the left. In the next example, you are asked to locate the discontinuities of the given function. Well, we are not asked to graph here, so try your best to do using algebra. So I have a rational expression here. So I'm going to start with the denominator term, which is 1 minus exponential 1 minus x squared. Whenever I have a rational expression, I always say that the denominator is not 0. It cannot be 0. But just for the sake of convenience to solve this equation, we assume it to be 0 and solve, but towards the end we are going to put the not equal to sign. Now you want to add 1 on both the sides, or like do a negative 1 on both the sides. Rewrite this equation. It's exponential 1 minus x squared with a negative sign equal to negative 1. You have a negative on both the sides, you can cancel them, negative, negative. Now you can write exponential 1 minus x squared equal to 1. Now you take ln on both the sides, the natural log on both the sides. When you do take ln on both the sides, you have 1 minus x squared ln e equal to ln 1. We all know that ln 1 is 0 and we know that ln e equal to 1. So you can say that 1 minus x squared equal to 0. Solve for x, you have x equal to 1 and x equal to negative 1. But remember, we did try to solve an equation with a not equal to sign. So at this point, I want you to add that not equal to sign by writing x is not 1 and x is not negative 1. Just for the sake of convenience of solving, we had equal to sign in every step. I want you to note that the very first step was not equal to, so towards the end your result should be not equal to. Now you want to draw a number line, mark 0, negative 1, 1, infinity and negative infinity. So the values of x, all you're saying is cannot be 1, cannot be negative 1. So leave out these points. After leaving out these points on the number line, read the value of the interval. It's negative infinity, negative 1, open, and then negative 1 to 1, open, and then 1 to infinity. So it's all these three intervals. So you're going to put union of all these three intervals. Question asks you to locate the discontinuities of the function f of x equal to 1 minus exponential 1 minus x squared. So the discontinuities are at 1 and negative 1. So this answers the continuous function. So these are the points 1 and negative 1 for which you see discontinuities. Next, find the intervals on which the following functions are continuous. You read carefully, the function is a polynomial. X squared plus 2x plus 1 is a polynomial. So this is a polynomial function. So whenever you have a polynomial, or even in the case when you have a trig functions, or when you have exponential functions, these should be the only functions and they should be in the numerator. then you can say that the intervals on which the function is continuous is the set of all real numbers, negative infinity and infinity. So question is asking you on what intervals is the function continuous. So the function is continuous on the entire real line. Next, you have a rational expression. So try to factor the denominator. You can write the denominator as x minus 6 and x plus 2 when you factor the quadratic expression in the denominator. So you always argue that the denominator should not be equal to 0. So write x minus 6, x plus 2 cannot be equal to 0. Again, this is for our convenience. We rewrite it as 0 and solve x minus c x plus 2 equal to 0. Solve for x, you have x equal to 6 and x equal to negative 2. But once you're done solving it, you have to understand that this actually comes with a not equal to sign. So all you say is x cannot be 6, x cannot be negative 2. So these 2 points are excluded. So now you read the interval carefully. It's negative infinity to negative 2. And then you have union negative 2 to 6. And then you have union 6 to infinity. So leaving out negative 2 and 6, you have the function to be continuous at all the other 3 intervals. The next one is a piecewise function. You have function defined on 2 interval values. One is x less than negative 3. So let me mark negative 3 and 3 here. For x less than or equal to negative 3, the function is defined as x minus 5 x plus 2. For x greater than 3, the function is defined as 2x squared. Now you want to read the function carefully. So you have negative infinity all the way up to negative 3. The function is defined. It's a rational function. When you start arguing the x values for a rational function, at the most you take this denominator term here. You say this cannot be equal to 0. So all you say is x cannot be equal to negative 2. But the function is restricted on negative infinity, negative 3 interval. So negative 2 is here. So the graph is nowhere going to touch negative 2. So you will not bring that to the discussion here. All you say is the graph of rational function x minus 5x plus 2 will lie on this interval negative infinity, negative 3. Union, you have one more interval. For x greater than 3, you have a polynomial. So you're going to write 3 all the way up to infinity. So just reading the graph, and negative 2 does not matter because it lies outside the interval negative infinity, negative 3. In the next example, you are asked to use the continuity definition to evaluate the limit. The continuity definition is this: limit x approaching f of x equal to fa. So wherever you have this x value, you're going to plug in x equal to a. So let's do that. In this example, we are going to write limit x approaching 1 f of x equal to f of 1. So now we write limit x approaching 1 e to the x square plus x. This is your f of x in the problem. Plug in the limit x equal to 1, 1 square plus 1. So this is 1 plus 1, and then we have e to the 2. In the next example, find the value of c such that f of x is continuous everywhere. Again, it's a piecewise function. You have 1 on the interval. For all the values less than or equal to 1, the function is 2x minus 5. For greater than 1, the function is x squared plus c. You want to find a c such that the function is continuous. So c is your unknown in the problem. First, I want you to write the limiting definition, continuity definition, x approaching a f of x equal to f of 1, or f of a in general. But you know that a here in the problem is 1 because these two are 1 here. And you understand you are going to discuss the limiting value when a is 1. So you're good to rewrite the limit definition with 1. Now you will calculate the left-hand limit, which is limit x approaching 1 minus f of x which is limit x approaching 1 minus. 1 minus means it's all the values which is less than 1. 1 plus means which is all the values greater than 1. So for 1 minus, the function is 2x minus 5. You read the graph carefully, the number line, and then plug in the limits. 2 times 1 minus 5, and this is negative 3. Similarly, you want to calculate the right hand limit. Limit x approaching 1 plus f of x. So this is all the function for which x is greater than 1, and the function is x squared plus c. Plug in x equal to 1. So you have 1 plus c. You know that when the function is continuous, the left hand limit and the right hand limit are equal. And in this problem, they've already given for you that the function is continuous, which means you're good to equate the left hand limit and the right hand limit. So negative 3 and 1 plus c should be equated. Do a negative 1 on both the sides, so negative 4 equal to c. So you can rewrite c equal to negative 4. So this is our final answer. Question did ask us to find the value of c, and we have found it to be negative 4. In the next example, find the value of a and b such that the function h of x is continuous everywhere. Again, it's been given for you the function is continuous. So with all those continuous definition and the properties, you're going to find the constants a and the b. So first let's start with step 1. We want to discuss what happens at the point x equal to 2. We will calculate two different types of limits here. One is the left hand limit. The other one is right hand limit. The left hand limit definition is x approaching 2 from the left. So we're going to write 2 minus f of x. Again, you read this as all the x values less than 2. So this is the x values less than 2. So you will write limit x approaching 2 minus x square minus 4 divided by x minus 2. Either you read as x less than 2 or you read it as x approaching 2 minus. On the number line, you understand that if you have a 2 here, the values are approaching 2 towards on the left. They all three means the same. So the function you want to choose is the first rational expression. Now plug in x equal to 2, you have 2 square minus 4 divided by 2 minus 2. Simplify, you have 0 over 0 form. If you remember 0 over 0 form, we have discussed before in the previous sections, we understand that this is an indeterminate form and we don't want this format. So what we do is we go back to this step and we rewrite the numerator as x minus 2x plus 2. We apply the difference of the square formula, and then denominator is x minus 2 itself. Now we are good to cancel x minus 2, x minus 2. At this step, we will evaluate the limit x approaching 2 minus for x plus 2. And this is 2 plus 2 when you plug in the limit value, and your answer is 4. Similarly, I want you to calculate the right hand limit. So the right hand limit will be limit x approaching 2 plus of the function f of x. So this is limit x approaching 2 plus the function f of x is ax square negative bx positive 3, x approaching 2 from the right, all the x greater than 2. So plug in x equal to 2, you have 4a negative 2b positive 3. And you know that the left hand limit and the right hand limit are equal. So you're good to equate them, LHL equal to RHL. So all you have is 4a minus 2b plus 3 equal to the one more limit is 4. So you can also rewrite this as 4a negative 2b equal to 1. So this is one equation we have with two unknowns. We want to find one more equations with two unknowns, and then we solve the system of equations. So step 2, let's write at x equal to 3. So how are we choosing this x equal to 2 and x equal to 3 in each of our steps? That comes from the inequality values here. You're seeing x less than 2, 2, 3 and 3 again. So we identify that we want to discuss the x values which is approaching 2 and approaching 3 from the left and the right. So at x equal to 3, you want to calculate the left hand limit, which is limit x approaching 3 minus from the left, and then you have f of x. 3 minus from the left is also x less than 3. So the function is limit x approaching 3 minus, you have ax square negative bx plus 3. Plug in simplify, you have 9a negative 3b plus 3. Similarly, do the right hand limit. Limit x approaching 3 plus f of x. This is limit x approaching 3 plus, this is 2x minus a plus b. Plug in the limit for all x greater than 3. This is 2, 3, negative a, and then plus b. Now again, you know that the left hand limit and the right hand limit are equal. So do this, equate left hand limit equal to right hand limit. Simplify the equation. You will have 10a negative 4b equal to 3. I want you to do this one-step calculation here, and then you see this equation. Now we have two equations with AB. I'm going to name this as equation 1 and equation 2. Two equations, two unknowns, we all know how to solve it. System of elimination, elimination method, 4a negative 2b equal to 1, 10a negative 4b equal to 3. So you can multiply 2 to the first equation, rewrite this as 8a negative 4b equal to 2, and then we can cancel the negative 4b and by subtracting the equation negative 4b and negative 4b, this becomes positive when you subtract all the sign changes. So simplify, you have negative 2a equal to negative 1. So you can say a equal to 1 half. When a is 1 half, you can plug in the equation 1 or equation 2 to find b. B also turns out to be 1 half. Question did ask us to find the values of a and b such that the function is continuous, and our answer is both a and b are equal to 1 half. In the next example, you're asked to sketch the graph of the function that is discontinuous, but it's going to be continuous from the right at 2. So you want to draw 2 on the x-axis. It should be continuous from the right. Continuous from the right, a curve is moving towards 2. It is continuous from the right. And it should be a closed point here. But discontinuous. But finally you want to make this graph discontinuous. So you can make some other curve coming from the left towards 2. But now you see that you have an open circle. So you open circle on the top, closed circle on the bottom. You see the graph is discontinuous. So function from the right is continuous. Continuous from the right at 2. But it's not continuous as a whole because you see a jump in the graph. Next example, sketch the graph of a function f that is continuous, except it has removable discontinuity at 1 and jump discontinuity at 3. So you mark the point 1 and the 3. Draw a continuous curve. There's removable discontinuity at 1, so make an open circle. Keep going until 3 and make a dark circle at 3. But you see that there's one more curve coming from the right towards 3, and now you make an open circle. And the question is asking you to make a jump discontinuity at 3. and you are seeing that you have a jump in the graph here, and the graph becomes discontinuity as a whole. So this is your removable discontinuity, and the other one is the jump discontinuity. In the next problem, you are asked to find the x value at which the function is discontinuous and also determine whether the function is continuous from the right or from the left or neither. And now before even you start doing the problem, you want to analyze at which point will you choose to discuss the left continuity or the right continuity. So read the limits carefully. You have a discussion at 0, 0 and 9 and 9. So this lets you know that you have to choose 0 and 9 for our limit value discussion. So you start by saying at x equal to 0, you want to calculate the left hand limit as well as the right hand limit. The definition of left hand limit, x approaching 0 from the left, 0 minus f of x. The right hand limit, x approaching 0 from the right, 0 plus f of x. When x is approaching 0 from the left, the function is 6 plus x squared. You read the piecewise function. So evaluate this function at x equal to 0. So this is 6 plus 0 square, which will give you 6. Similarly, when x is approaching 0 plus 0 from the right, so it's x greater than 0, the function is 9 minus x. Plug in, you have 9 minus 0, so it's 9. And you see these values are not the same, so you say that the function is discontinuous. You also discuss the value exactly at x equal to 0. F of x equal to 6 plus x squared function. You have an equality sign, so you choose 6 plus x squared. Calculate f at 0 and you see that you have 6 as the value. From the left, the limit value is 6. Exactly at 0 also the limit value is 6. So combining these definitions, you can say it's continuous from the left. So if you try to draw a rough graph, negative infinity, infinity, approaching like this from the left towards 0, and then you have a straight line, you see a jump. The function is not continuous as a whole, but it is continuous when it's coming from the left. This is just a sketch of the graph. The next point of discussion will be 9. So you want to write at x equal to 9. You want to see the left hand limit and the right hand limit calculations. So limit x approaching 9 minus f of. So limit x approaching 9 minus x. Plug in 9, you have the value as 0. Next limit x approaching 9 plus f of x. So this is limit x approaching 9 plus 9 minus x the square, or read the function carefully, it's the other way around, it's x minus 9 the square. For all x greater than 9, the function is x minus 9 the square. Plug in the values, x equal to 9, you see the limit value is 0. So all you're seeing is the left hand limit equal to the right hand limit, and the values are 0, they're the same. So you might be tempted to say that the function is continuous. But I also want you to check exactly at x equal to 9 what's the value. At x equal to 9, the function f of x, you want to consider it 9 minus x. So plug in x equal to 9, so f of 9 will be 9 minus 9, which is 0. So now you're good to say that the function is continuous at x equal to 9. So in this problem, we were asked to find the x values for the function is discontinuous and the x values for which the function is continuous. So it's discontinuous at x equal to 0 and it's continuous at x equal to 9. So we'll end this section here.